Hey guys, hope everything is going well. This week we're going to focus on Unit 8, which was all about exponents and logs. And we're going to break this up into two parts. We're going to do part 1 in one Edpuzzle, then you'll take a Go Formative quiz, and then part 2 and another Go Formative quiz. So let's go ahead and get started by solving exponential equations with common base. So I can write something like this: 2 to the 3x plus 4 equals 8 to the 2x minus 9. Now remember, you can write your exponents with or without the parentheses. It doesn't matter, so you might see it both ways depending. And what we're going to do is take a look at our lowest base here to see if maybe we can use that to rewrite our higher base. So I'm going to rewrite 2 to the 3x plus 4. And then I know that 2 to the third power is equal to 8. So I'm just going to rewrite 8 as 2 to the third power. That's my base. And then the 2x minus 9. Now, if you think back to Math 1, when we had power to a power, we had to multiply these numbers. So again, I'm going to rewrite this side as 2 to the 3x plus 4 equals 2. So my base stays 2, but then I have to multiply this 3. So 3 times 2x is 6x, and 3 times 9, negative 9, is negative 27. Now, if you were just asked to rewrite, you would stop right here. But if we want to go ahead and solve for x, now that the bases are the same, we can just take our exponents here, 3x plus 4, and set it equal to 6x minus 27. I personally like to keep my variable positive, so I'm going to subtract 3x from both sides here. But if you wanted to subtract 6x, you could do that as well. And then I'm going to go ahead and add 27 to both sides. So I'm going to get 31 equals 3x. Divide by 3. And you can leave it as a fraction if you want to, or if you want to do a decimal, you can do that as well. Either answer is fine. All right, let's take a look at solving using logs. So if I have something like this, log base x of, say, 54 equals 3. And we want to go ahead and solve for x. So what we're going to do is we're going to use what we learned by rewriting logs into exponents. So remember, the base of the log becomes the base of the exponent. So that x is the base of the log. That's going to be here. And we're going to switch these two around. So it's going to be x to the third power equals 54. So that's to start. We're just taking our log and we're converting it into our exponent. Now here, if I want to solve for x, I have to undo that third power. So to undo that, I'm going to take the third root. Remember, when you put the third root over here, it just gets rid of that exponent. So you're left with x is equal to the third root of 54. To find third root in your graphing calculator, you're going to use the math key right here. So hit math. And the third root is the fourth one down, so you can either hit the number 4 or arrow down and hit enter. And then I'm just going to put in my 54, and so x is equal to 3.78. Let's take a look at some natural logs now. So if we want to go ahead and solve an equation with natural logs, so let's say I have a natural log of x minus 4 equals 20, and I want to solve for x here. Well, the inverse of the natural log is our number e, so what we have to do is we have to take e to this whole power here to get rid of that natural log. So I'm going to take e, and then this is my entire exponent, but what I do to one side, I have to do to the other side. So this goes away, and I'm left with x minus 4 equals e to the 20th. To get x by itself, I'm just going to add 4 to both sides. So I'm going to get x is equal to e to the 20th plus 4. This would be considered your exact answer. If you want to get a decimal for this, you can use your calculator here. So the e is the second natural log key. So here's your natural log right next to the 4. If you look above, you'll see e to the x. So you just hit second natural log. There's my e. I put that to the 20th. Now, depending on your calculator, some will show the exponent up here like mine. Some will just show it with the little caret and the parentheses. So you will want to close your parentheses. For mine, I'm just going to use the right arrow and hit that to bring that back down. Hit plus 4. And so we got a pretty big number here. So you can leave it like this, or you can have the exact answer here. This would be your estimated answer. Keep in mind that you cannot add this 4 to the 20. This is something separate. This is like saying x to the 20th or something like that. You cannot combine those. Now, if we want to look at an equation where we start with e, let's say we have 3 to the e, or excuse me, 3e to the x plus 2 equals, we'll do 33. Before we can do anything here, we have to make sure that we clear off anything that is multiplied, or if we were adding or subtracting over here. So I'm going to divide by 3 first. So now I have e to the x plus 2 equals 11. I'm not adding or subtracting anything outside. I'm not multiplying here, so I can take the natural log of both sides because the natural log is the inverse of e. So I'm going to take the natural log here, but what I do to one side, I have to do to the other. That's going to clear that out. So that just gets rid of that because it's the inverse. So I am left with x plus 2 equals the natural log of 11. Then in order to get x by itself, we would subtract 2 from both sides. Now, just like we talked about over here with our e, we cannot combine this. It's the same thing over here. We cannot combine 11 and negative 2. This would not be the natural log of 9. Your exact answer would be x is equal to the natural log of 11. So whatever that value is, and then subtract 2 off. If you do want to get an estimated answer, you can use your natural log here, 11, but then make sure you close your parenthesis and subtract 2. This, of course, though, is your exact, and this is your estimated. The last problem we're going to do talks about change of base. So let's go ahead and solve this problem. Let's say we have 7 to the x is equal to 148, and we want to solve for x. Now there is no integer value of x that I can put in here where I'm going to take 7, to the third and get 148. So I'm going to have to use change of base for this. So we're going to use what we learned, converting to logs. Remember, the base of the exponent becomes the base of the log. And then these two values switch. So I'm going to have log base 7 of 148 is equal to x. When we have this written here, we can use change of base. Remember, base goes to bottom. So when I write this out as a fraction, I'm going to put log 7 in the bottom, in the denominator. Base goes to bottom, and then what's left goes in the numerator, in the top. We're going to use our calculator again. The log key is right next to the 7. So I'm going to put log 148. And again, this is really important that you close your parenthesis here. Otherwise, it's going to take log 48 divided by log 7. So you want to close that parenthesis before you're dividing by your log 7. So x is going to be 2.57. All right, go ahead and do the Go Formative. Let me know if you have any questions. You can send an email. You can ask a question here on Edpuzzle, put a comment on Google Classroom, or attend one of the Zoom meetings. Hope you have a great week. Thanks. Bye.